doing as Center for Intelligent Product Development, and it's called Intelligent Product Design Workshop. And in this particular course, the students are expected to uh, build a prototype. Build a prototype means not just something based on modules, but something based on PCBs aligned to the shape of the final product that you want to create. So they will have to 3D design their product bodies. They will have to identify the shape of the PCB accordingly, and then they will have to design the PCBs so that the final product, the final prototype appears similar to what the product would look like. And then they can improve on the prototype uh, in terms of both body and hardware and various aspects of it. So they have already been through a few sessions on how to identify which microcontroller to use, what kind of things to work on. And in the past week, they also gave a presentation on uh, their, proof of concept, which would be based on industry standard modules. They are presently working on these proof of concepts, and we will hopefully see something within this week as a part of their proof of concept presentation and submission. So since the next step is PCB design, this is the most appropriate time for you people to join and help our students understand the nitty-gritties, the intricacies, starting from how to define the shape, given the shape of the body. Things like where to place the heat sinks, things like where to place the magnetometers. For example, we have a team amongst us, which is also a startup. They're designing a on-flight drone controller, and they're presently using something that was a PCB that was designed elsewhere, and what they are facing is that the magnetometer is not working properly because of electric currents that are running around that particular chip, which are generating their own magnetic field, and the magnetometer is not able to guide them in the navigation. So these little aspects, which can be detrimental even the functionality of the design, यहाँ से लेके even talking about uh, IR drop and signal integrity and all those things, high speed signal transfer and all those things. These are aspects that we want to introduce the students to. So I know this is the first session, so we'll not go into each and every detail today, but uh, let's start from where you can possibly ask a few questions, gauge where the students are, and then modulate your session accordingly. So over to you guys.
Okay, thank you, Dr. Anuj. So let me also add few things here. So I invited Balmukund to present this PCB designing using KiCAD. So KiCAD is a free tool. We are aware that you have been including Eagle as a tool for PCB design, which is also the case in most of the universities. However, recently we have seen that KiCAD is gaining a lot of attraction, considering this is supported in open community. So it's an open source tool first. Secondly, there are no licensing requirement because of this. I mean, that's understood. But also many companies, professional companies, are switching over to KiCAD for their PCB design. In fact, inside ST, we have been using OrCAD and Altium since quite a long time because these are licensed tools, but also quite costly. Also on our side, there is an effort to make few designs on KiCAD and do comparative analysis of how professional tools and these free tools, what kind of facilities they provide. So using that experience, Balmukund is going to present. Additionally, I requested Rajesh Galotra ji to also join. In fact, he's running a startup on this PCB design technologies. I mean, he has a wide experience in industry. I came to know about him in one of the forums, and then we started to talk about some PCB design. So he's also doing our design on KiCAD as a third party company. But inside ST, Balmukund and few people have taken this initiative to try KiCAD and make some end product or for us, which are like ST eval boards that some of the students have seen during their visit to ST last week. So some reference design are done on KiCAD. So that's the background for everyone. So now, so myself and Balmukund are together in a room. I'll mute myself and Balmukund will start to present. We kept the video off just to save the bandwidth because we have seen that earlier. Additionally, we are not so conversant with the Zoom. We use Microsoft Teams as a tool. So if we face some issues, please help us in that. But for now, I can see Balmukund is able to share the screen and is going to present. So I let Balmukund now present and take it from here. Thanks. In parallel, please put your questions in the chat. Sorry, I think now it should be Balmukund's mic and speaker. So what I was saying is, please put your questions in the chat, and of course, please do stop to ask questions. Balmukund will try to answer. If there are something which we are not able to answer, I mean, there could be possibilities. So Rajesh ji, please do also jump in to answer those kind of questions, or we can answer them offline by finding a suitable. Sure, sir.
Okay,
sure, sir. So over to Balmukund. Thanks.
Okay, so good morning all. In this session, I will be presenting about, not presenting, we don't have any presentation. We will be directly running the software from starting from a schematic, and we will do one layout, a full layout, and also we will generate curve, and we will see different features of the KiCAD. The the advantage of KiCAD is Alok already told that it is free, open open source, and also it's easy to use. So it can be downloaded from the KiCAD.org. It is available for multiple OS. It can be directly downloaded from here. Suppose I want to download it for Windows, so I will just click on Windows, and we can select any one. So you can see download started. So I have already the software, so I will just download. So this is the KiCAD I have already installed. The version is 8.0. Okay, so we will start from very beginning. So we will then make one simple schematic, and then I will port it for the layout, and we will do the layout. So these are different features. A schematic, it can be used for different things. A schematic, symbol editor or PCB, also footprint editor, Gerber viewer also. So if there is any Gerber, it can be open here. Then image converter, this is for putting some logos on the PCB. Then calculator for calculating the track width and those things. Okay. So these are different features. So we will mainly see the schematic and PCB, schematic editor and PCB. So let's create new project.
सॉरी टू इंटरप्ट, अगर आप अलाउ करें तो मैं उसमें कुछ और चीज ऐड करना चाहूंगा सर इस सेशन से पहले.
जी राजेश जी, गो अहेड.
थैंक यू सर, थैंक यू. एक्चुअली मेरा मेन मोटिव चीज बीच में ऐड करने का ये है कि सबसे पहले हम लोगों को ये पता होना चाहिए कि पीसीबी होता क्या है. उसके बाद हम सेकंड स्टेप में ये करेंगे कि पीसीबी को डिजाइन कैसे करते हैं. तो पीसीबी क्या होता है उसके बारे में मैं थोड़ा सा बताना चाहूंगा सर. राइट सर. उसके लिए मैं अपनी स्क्रीन शेयर करने वाला हूँ. प्लीज अलाउ सर.
Somebody from Triple IT team have to
help to make Rajesh ji as co-presenter?
So आलोक आप भी कर सकते थे लेकिन मैंने कर दिया अभी.
Okay, I'm not so conversant with Zoom, Anuj. Rajesh ji, are you able to share your screen?
मेरी स्क्रीन विजिबल है सर जी?
Not yet.
नॉट येट. ओके. आई थिंक अपनी टीम में से किसी को अलाउ करना पड़ेगा मुझे सर. व्हाट आई थिंक सो.
राजेश आपको co-host बना दिया. You should be able to share
ओके.
now.
राइट सर, राइट सर, राइट सर. होस्ट डिसेबल्ड पार्टिसिपेंट स्क्रीन शेयरिंग ऐसा आ रहा है मैसेज सर.
यार लेकिन आप तो co-host हैं already. So
सर
एक बार फिर से ट्राई करिए. नहीं तो मुझे एक मिनट दीजिए, मैं दोबारा से.
बिकॉज उसके ऊपर जो नीचे आ रहा है सर, शेयर के ऊपर अगर मैं कर रहा हूँ, क्लिक करता हूँ तो वहां पे आ जाता है होस्ट डिसेबल पार्टिसिपेंट स्क्रीन शेयरिंग सर.
Yeah, but you're already a host now. That is what I'm surprised about.
ओके ओके ओके. यस सर.
Just
लेट मी
a
ट्राई
minute.
सर. लेट मी ट्राई सर.
Yeah, you while you share, you can already start to speak. I'm just taking it the other way out.
Rajesh ji, there would be a up arrow on the bottom of the screen on the Zoom. If you can do, otherwise we can take it up in the last. If you or you can just summarize by audio. सर आप म्यूट भी हैं राजेश.
यस सर.
Are you able to find the sharing button? Because it's
शेयरिंग बटन, आई एम एबल टू फाइंड द शेयरिंग बटन, बट स्क्रीन शेयर नहीं हो पा रहा सर जी.
so maybe okay. So let's do like this. You just
ओके ओके. नो नो इशू
summarize
सर.
by audio. हाँ
ओके.
जी, हाँ जी.
राइट सर जी. राइट सर. राइट सर.
तो would you like to share? आप कुछ बोलना चाहेंगे?
सर एक्चुअली मैं शेयर करना चाह रहा था लेकिन बाई चांस
राजेश,
वो हो नहीं
अभी
पा
ट्राई
रहा.
करिए.
तो ठीक है,
अभी एक
बालमुकुंद
बार
जी
ट्राई
आगे
करिए.
प्रोसीड कर सकते हैं.
राजेश एक बार अभी ट्राई करिए फिर से प्लीज. एक बार अभी फिर से ट्राई करिए.
Yeah, now we see. Rajesh ji, we can see your screen now.
ओके सर. थैंक यू सर. थैंक यू.
Yeah, it was not about host disabling. It was more about there were two people sharing. बालमुकुंद की भी शायद स्क्रीन शेयर थी और आपकी भी थी, इसलिए कुछ हो रहा था.
श्योर सर. श्योर.
Oh, okay.
सर सबसे पहले मैं अपने बारे में बताना चाहूंगा. आई एम राजेश कलोत्रा, हैविंग मोर देन 25 to 30 ईयर एक्सपीरियंस इन द सेम फील्ड. और हमने जो नया स्टार्टअप किया है उसका नाम है पीसीबी ए टू जेड. सबसे पहले हम लोगों के माइंड में आता है कि भाई पीसीबी ए टू जेड, पीसीबी का नाम तो ठीक है, ए टू जेड क्यों रखा गया? ए टू जेड का मतलब ये है कि हमारे पास पीसीबी डिजाइन की एक्सपर्टीज है, हम पीसीबी फैब्रिकेशन कर रहे हैं, हमारे पास पीसीबी असेंबली का भी सेटअप है, उसके अलावा इलेक्ट्रॉनिक कंपोनेंट सोर्सिंग का हमारे पास कंप्लीट सेटअप है. सो हम कह सकते हैं कि दिस इज द पीसीबी ए टू जेड. और आज का उसके ऊपर बहुत ज्यादा टाइम ना देते हुए हम स्टार्ट करते हैं पीसीबी डिजाइन ट्रेनिंग. पीसीबी डिजाइन ट्रेनिंग की बात करें तो देयर आर टू टाइप ऑफ ट्रेनिंग्स अवेलेबल इन ग्लोबल मार्केट. एक तो है ऑफलाइन ट्रेनिंग, सेकंड होती है ऑनलाइन ट्रेनिंग. ऑफलाइन ट्रेनिंग के अंदर तो जो डोमेस्टिक हमारे पास एज यूजुअल हो रहा है, उसमें हम लोग कोई भी कैंडिडेट्स जाते हैं, ट्रेनिंग लेते हैं और वापस आ जाते हैं. जस्ट लाइक ए क्लासरूम सेशन होगा। लेकिन ऑनलाइन ट्रेनिंग में बहुत ज्यादा बेनिफिट्स भी हो गए हैं। उसमें यह है कि हमारा टाइम काफी ज्यादा सेव हो जाता है, आने जाने का टाइम, और उसके बाद क्लासरूम वाला सेशन है उसका भी किया जा सकता है, क्योंकि जो ऑनलाइन वाला है उसको हम चाहें तो रिकॉर्ड भी किया जा सकता है। वो एक एडिशनल बेनिफिट भी हो गया हमारे पास। और मजे की बात यह है कि हमारे पास ये जो सेशन हम स्टार्ट करते हैं, जो ट्रेनिंग अब प्रोवाइड कर रहे हैं अब यहाँ से, उसमें 1:1 ट्रेनिंग भी है और ग्रुप ट्रेनिंग भी है। लेकिन ग्रुप ट्रेनिंग में हम लोग प्रेफर इसलिए करते हैं कि उसमें क्रॉस क्वेश्चनिंग हो जाता है, कि बिकॉज 2 3 4 5 10 20 25 50 जितने भी कैंडिडेट्स ज्यादा होते हैं, उतना लर्निंग का एक्सपीरियंस थोड़ा सा ज्यादा हो जाता है, बट आई फील सो। और पीसीबी के साथ एक नाम जुड़ा हुआ है, पीसीबी डिजाइन। अब बहुत सारे पर्सन्स पीसीबी डिजाइन सीखते भी हैं, लेकिन जो एक्चुअल में मार्केट में देखने को आया है कि बहुत सारे पर्सन सीखने के बाद भी उसके अंदर फील्ड के अंदर सक्सेसफुल हासिल नहीं हो पा रहे। उसका एक मेन रीजन है कि किसी भी पर्सन को अगर पीसीबी डिजाइन फील्ड के अंदर 100% सक्सेस हासिल करनी है, तो उस पर्सन के पास एटलीस्ट 3 क्वालिटीज जरूर होनी चाहिए। अगर वो 3 उसके पास क्वालिटीज नहीं है, जो 3 उसके पास चीजें नहीं है, तो वो सक्सेस हासिल नहीं कर पाएगा। जो हम लोगों ने फील किया है, जो मैं आप लोगों के साथ शेयर करने वाला हूं। सबसे पहले टेक्निकल बैकग्राउंड। कोई भी पर्सन जो पीसीबी डिजाइन के फील्ड में आना चाह रहा है या आएगा, उसके पास टेक्निकल बैकग्राउंड होने चाहिए। बेशक रेजिस्टेंस, कैपेसिटर, डायोड, आईसीस उसके पास बहुत ज्यादा डिटेल में ना भी पता होगी कैसे काम करता है, लेकिन इतना जरूर पता होना चाहिए कि ये सिंबल किस चीज का है। अगर वो भी नहीं पता, तो शायद इस फील्ड में आने के लिए उसको बहुत ज्यादा मुश्किलें आएंगी। और वो बड़ा आसान है, बेसिक नॉलेज वो कहीं से भी ली जा सकती है। लेकिन मुझे ऐसे यहाँ पे बताने की जरूरत नहीं है कि हमारे पास यहाँ पे सभी क्वालिफाइड प्रोफेशनल्स अवेलेबल हैं, या जो स्टूडेंट भी अवेलेबल हैं वो एटलीस्ट इलेक्ट्रॉनिक्स के हैं या इलेक्ट्रॉनिक्स के बारे में कुछ जानते हैं। सो फर्स्ट वाला जो फेज है वो हमारा कंप्लीट हो जाता है। अब बात करते हैं सेकंड। पीसीबी के साथ आता है डिजाइन। जब डिजाइन की बात आए तो एस्थेटिक्स की बात आती है। जब कोई भी चीज, डिजाइन का मतलब होता है कि कोई भी चीज खूबसूरती के साथ ड्रॉ करना, तो वो भी क्वालिटी मोस्ट ऑफ द पीपल के अंदर अगर नहीं है तो वो अडॉप्ट की जा सकती है। और मार्केट के अंदर देखने को आया है कि गर्ल्स के अंदर ये क्वालिटी बहुत अच्छा तरीके से होती है, क्योंकि बाई बर्थ उनके पास एक, कह सकते हैं, गॉड गिफ्टेड एक ऐसी चीज है कि खूबसूरती से किसी चीज को ड्रॉ करना और विजुअलाइज करना उनके पास रहता है। ये तो एक जनरल बातें हो गई, लेकिन जो तीसरी मैं क्वालिटी बताने वाला हूं, वो मोस्ट ऑफ द 90% पीपल के पास नहीं होती। जब तक वो भी किसी भी डिजाइन इंजीनियर के पास नहीं होगा, तो वो 100% सक्सेस हासिल नहीं कर पाएगा। वो क्या है? दैट इज ए पेशेंस। क्या पेशेंस सभी के पास होती है सर? शायद नहीं। तो पेशेंस का मतलब ये नहीं है कि किसी के साथ लड़ाई झगड़ा करना है। पेशेंस का मतलब ये है कि कई बार कहीं ऐसी चीजों में हम फंस जाते हैं डिजाइन करते करते, कि हम लोगों को बड़े पेशेंसली किसी तरीके से रूटीन को दोबारा से भी किया जा करना पड़ सकता है। तो वो चीज हमारे अंदर क्वालिटी होनी चाहिए। अगर ये तीनों चीजें अवेलेबल हैं, तो हम एक परफेक्ट डिजाइन इंजीनियर बन सकते हैं। दूसरी बात ये है
Rajesh ji, you have to be
supervision.
fast. Rajesh ji, you have to be fast also. We have to conclude within 1
Okay,
hour.
sir. Okay, sir. Okay, sir.
Yeah,
Got the point,
please.
sir. Got the point. अब हम लोगों के विजन की बात करें, तो अवर विजन इज टू ब्रिंग न्यू मेथडोलॉजी इन ट्रेनिंग एंड गिविंग बेस्ट पॉसिबल लर्निंग सॉल्यूशंस टू द लर्नर्स। इसका एक्चुअल में मतलब क्या है? मैं अभी जो स्टूडेंट्स हैं उनके साथ थोड़ा सा इंटरेक्ट करना चाहूंगा। कोई भी एक स्टूडेंट मुझे बता सकते हैं कि आपका फेवरेट सब्जेक्ट कौन सा रहा है? यस फ्रेंड्स, एनीवन प्लीज। इट्स नॉट ए टेस्ट, जल्दी जस्ट एक कन्वर्सेशन है आपस में। हेलो, मेरी आवाज आ रही है प्लीज?
Yeah, you are audible.
Yes. कोई भी पर्सन बता सकता है उनका फेवरेट सब्जेक्ट कौन सा रहा है लास्ट?
Harsh, we could not hear you. I think you were
Yes, sir.
trying to speak.
Right, sir?
So, sir, for the past, I think specifically in the past a couple of months, I've taken on PCB design, schematic design, and
नहीं,
worked
सर, दैट इज ए सेशन ना सर। अपना जो इलेक्ट्रॉनिक्स में हमने किया है, इंजीनियरिंग में किया है, उसमें फेवरेट सब्जेक्ट कौन सा रहा है?
It's been robotics, I think.
रोबोटिक्स, वेरी गुड सर। अब एक मैं छोटी सी बात और आपके साथ शेयर करना चाहूंगा या आपके साथ कन्वर्सेशन करना चाहूंगा कि रोबोटिक्स का जो फर्स्ट चैप्टर का नाम याद है?
Inverse kinematics.
मोस्ट ऑफ द टाइम्स मोस्ट ऑफ द पर्सन के साथ होता है। सपोज करो अगर उन्होंने +2 किया है, +2 के बाद वो जंप करते हैं इंजीनियरिंग के अंदर, उनका अगर फेवरेट सब्जेक्ट सपोज करो मैथमेटिक्स रहा है या इलेक्ट्रॉनिक्स रहा है या सपोज करो कह सकते हैं कि इलेक्ट्रिकल्स रहा है या फिजिक्स या केमिस्ट्री कोई भी रहा है, तो मोस्ट ऑफ द पीपल जो होते हैं उस सब्जेक्ट का नाम भूल जाते हैं पहले चैप्टर का। लेकिन अगर यही बात बोली जाए कि कितने आदमी थे, तो शायद सभी के माइंड में आता है, सर आप शोले का डायलॉग बोलने वाले हो ना। तो हमारा जो एजुकेशन का जो मेथडोलॉजी है, किस तरीके से हम इंटरेक्ट करके ट्रेनिंग दे प्रोवाइड करते हैं, वो जस्ट लाइक ए फन हो जाता है। उसको बहुत ज्यादा माइंड में ये नहीं आता कि हमें बहुत सारी बुक्स पढ़नी पड़ेंगी, बहुत सारे नोट्स को रेफर करना पड़ेगा। हम बड़े हंसते खेलते आपस में इंटरेक्ट करते करते पीसीबी डिजाइन सीख सकते हैं और सीख जाते हैं। We are a source for PCB layout design services, CAD/CAM training, and global component sourcing, in addition to embedded project kits. Welcome to future. Yes, my dear friends, this is the future. Without the knowledge of PCB layout design, किसी भी इलेक्ट्रॉनिक इंजीनियर की क्वालिफिकेशन इनकम्प्लीट है। अगर हम सेमीकंडक्टर्स को इलेक्ट्रॉनिक्स की आत्मा कहते हैं, तो पीसीबी इज द स्केलेटन। इसको हम कह सकते हैं कि दिस इज ए पिज्जा बेस। पिज्जा तो सभी ने खाया होगा ना सर। अगर उसके अंदर डफ या बेस ही अवेलेबल नहीं है, तो फिर कैसे खाएंगे? शायद उसको चम्मच के साथ खाना पड़ेगा सर। सो दिस इज द इंपॉर्टेंस ऑफ पीसीबी। हमारा जो मेन ओवरव्यू है जो हम डिस्कस करने वाले हैं आज के सेशन के अंदर, उसके अंदर 2 पॉइंट्स आएंगे। सबसे पहले एक पॉइंट को मैं डिस्कस करूंगा और दूसरा बालगोनाथ सर करेंगे। जो फर्स्ट पॉइंट्स मैं डिस्कस करने वाला हूं वो है व्हाट इज प्रिंटेड सर्किट बोर्ड, होता क्या है। और उसके बाद जो नेक्स्ट सेशन होगा वो होगा हाउ टू डिजाइन ए पीसीबी। व्हाट इज प्रिंटेड सर्किट बोर्ड, उसके बारे में कुछ जानना चाहेंगे। तो वो क्या है? आज से तकरीबन 30 साल
Rajesh,
yes,
just एक चीज, and that was why I also shared the background. Most of the students have done a PCB design thing in their one of the labs.
Okay. Right, sir.
So we can, while we can quickly go through this, I think it would be important to actually talk about the nitty-gritties of, because this is a workshop course. This is not, these are all final year students. They're not first year students.
Sorry, sir, I was not aware of this.
Yeah. So that's okay. Yeah, that's okay. So आप थोड़ा सा introduction वाले part को quickly आगे ले जाके, what would be really interesting for them to understand is case studies, कि हमने ये एक PCB डिजाइन करा, इसमें इस तरह का एरर आया तो ये चैलेंज रहा, हमने इसको ऐसे ठीक करा. Those case studies are something that these students would be most interested in.
Right.
So
sir,
because
right,
you have such vast experience, that is exactly what we are looking forward to.
Very true. Because मेरी नॉलेज में था कि अभी पीसीबी के सेशन में नए पर्सन्स हैं, that is why I have opened this.
Yeah, I understand. I'm sorry for that confusion, but yeah,
Yes,
these are all students who have designed at least some PCB or another earlier at a very basic level, but they understand what a PCB is. So we can probably move a little faster on these early slides and focus more on the case studies later.
Within 5 minutes, I am going to close now. Okay.
Sure.
So स्टार्टिंग में पीसीबी की बात करें तो इलेक्ट्रॉनिक कंपोनेंट्स आर देयर, जिसको हमने आपस में ज्वाइन करके एक पीसीबी बनाना है, एंड दिस इज आवर पीसीबी। आज की डेट में कॉलेजेस में, यूनिवर्सिटीज में या स्कूल्स के अंदर हम लोग इस टाइप का ब्रेडबोर्ड यूज करते हैं, बट अवर टारगेट इज दिस थिंग। सो प्रिंटेड सर्किट बोर्ड को समटाइम्स हम पीडब्ल्यूबी बोला जाता है, दैट इज अगेन ए प्रिंटेड वायरिंग बोर्ड। सो व्हाट इज पीसीबी, दैट वी ऑलरेडी नो। पीसीबी को हम कहते हैं प्रिंटेड सर्किट बोर्ड, द इलेक्ट्रॉनिक बोर्ड दैट कनेक्ट सर्किट कंपोनेंट्स, और जो पॉपुलेटेड जिसके ऊपर इलेक्ट्रॉनिक कंपोनेंट लग जाते हैं उसको कहते हैं पीसीए, प्रिंटेड सर्किट असेंबली। कैड के अंदर हमारे पास पीसीबी इस तरीके के देखने को मिलता है, और फाइनली हमारे पास पीसीबी ये इसका बना हुआ है। फंक्शंस ऑफ पीसीबी में क्या आता है? टू इंटरकनेक्ट द इलेक्ट्रॉनिक कंपोनेंट इलेक्ट्रिकली। और इन सम केसेस एक मजे की बात मैं आपके साथ जरूर डिस्कस करना चाहूंगा, वो ये है इन सम केसेस रिप्लेस सम पैसिव कंपोनेंट रेजिस्टेंस कैपेसिटर और इंडक्टर्स। पीसीबी के अंदर हमने फिजिकली रेजिस्टेंस या कैपेसिटर नहीं लगाया, फिर भी वो वहां पे काम कर रहा है, ऐसा कैसे हो गया? इसका मतलब क्या है? इनडायरेक्टली मैं क्या बताना चाह रहा हूं कि पीसीबी के अंदर जो ट्रैक्स होते हैं उनका डिस्टेंस कम से कम रखना पड़ेगा, अदरवाइज एक वर्चुअल रेजिस्टेंस उसके अंदर जनरेट हो जाता है। उसके बाद करते हैं कैपेसिटर। कैपेसिटर की बात करें तो कैपेसिटर की अगर डेफिनेशन की बात करें तो टू कंडक्टिव प्लेट सेपरेटेड बाय इंसुलेटर इज नोन एज कैपेसिटर। जो डबल साइडेड पीसीबी है या जो मल्टी लेयर पीसीबी है उसके अंदर क्या होता है, कंडक्टिव प्लेट्स ऊपर भी होती है और नीचे भी होती है और बीच में एक सेपरेटर हो गया। सो पीसीबी जो है एक्टिंग एज ए कैपेसिटर है। इसका मतलब इनडायरेक्टली मैं क्या कहना चाह रहा हूं कि जो डबल साइडेड पीसीबी है या जो मल्टी लेयर पीसीबी है उसके अंदर नॉइस लेवल कम होगा एज कंपेयर टू सिंगल साइड लेयर पीसीबी। बेस मटेरियल क्या होता है आज की डेट में? थिकनेस जो कॉपर फॉइल जो इसमें जो होती है बेस मटेरियल इज FR1 है, FR4 इज देयर। और थिकनेस ऑफ कॉपर फॉइल 17 माइक्रोन, 35 माइक्रोन, 70 माइक्रोन भी अवेलेबल है। पार्ट्स ऑफ पीसीबीज में कंपोनेंट पैड, ट्रेसिस, पैड्स, वायर्स, टॉप मेटल लेयर एंड बॉटम मेटल लेयर होते हैं। कंपोनेंट्स क्या है, पैड्स क्या है, ट्रेसिस क्या है, बिकॉज ऑलरेडी आप पीसीबी के बारे में जान रहे हैं तो इसलिए मैं इसको स्किप कर रहा हूँ। टॉप मेटल केयर लेयर क्या होती है, बॉटम मेटल लेयर क्या होती है, जंपर्स क्या होते हैं, शोल्डर मास्क क्या होती है, सिल्क स्किन क्या होती है। ये हमारा एक पीसीबी है और दिस इज द टॉप साइड एंड दिस इज द बॉटम साइड। सिंगल साइड पीसीबी बनता कैसे है? ब्लैंक कलर की कटिंग किया, ब्रशिंग किया, उसके बाद इमेज ट्रांसफर, ये हमारे पास होता है। हमारा जो पीसीबी डिजाइन के अंदर प्रोसेस रहता है कि फिल्म जनरेशन तक का है, उसके बाद हमारे पास जिस साइज की हमारे पास फिल्म है उसी साइज की हमारे पास रॉ मटेरियल की कटिंग हो जाएगी। और अगर सीएनसी मशीन का डाटा है तो सीएनसी मशीन के ऊपर पहले हम ड्रिलिंग कर लेते हैं सीएनसी से। उसके बाद इमेज को ट्रांसफर किया, स्टिपिंग और एचिंग किया, शोल्डर मास्क करने के बाद शोल्डर कोटिंग कर दिया और फाइनली सिल सीन बना के हमारा पीसीबी इज रेडी। अब पीसीबी डिजाइन की टूल की बात करेंगे तो सो मेनी लार्ज वैरायटी ऑफ टूल्स आर अवेलेबल इन ग्लोबल मार्केट, बट हम यूज करने वाले हैं KiCAD। KiCAD के लिए मैं दोबारा इनवाइट करना चाहूंगा बिल्कुल नाथ सर को कि वो इसमें स्टार्ट करें। और उसके लिए दो हमारे पास सेशन रहेंगे। सबसे पहले तो रहेगा स्मेटिक एडिटर और उसके बाद है पीसीबी लेटर। और जहां से स्टार्ट सर ने अभी कॉमन लगाया था तो वहीं पे एक्चुअली मैंने वो ले लिया था। अभी मैं दोबारा सर के पास फॉरवर्ड कर रहा हूँ। सर प्लीज अपनी स्क्रीन शेयर करिए।
Okay, thank you, Rajesh ji, for that refresher.
Thank you, sir. Thank you.
I'll share your details with the students. If anyone wants to directly talk to you.
Yeah. And also Rajesh ji, मैंने आपको interrupt करा, sorry for that, but we would really be interested to understand your experience on the complexity in PCB design. These
Yes, sir,
basics
yes.
are fine. These basics, most of these students already know.
True.
And
Actually, I was
what is
not aware.
really,
Sorry, sir.
हाँ, नहीं, मैं समझ रहा हूँ. So we would want to hear you more later in the session or in the next session, ताकि we can actually, gain from your experience.
Sure, sir. Sure, sir.
Yeah.
Thank you, sir. Thank you. Malbukan, sir.
राजेश जी, आप अनशेयर करेंगे मे बी?
ये सर
हमारा शेयर क्या अनशेयर हुआ था?
Is Balmukund's screen visible?
नहीं सर, not available, sir. Not visible.
Rajesh ji, you have to unshare because I am able to see your screens too.
Okay. Screens. Yes, sir. Now it's available,
Now,
sir.
Okay, so I will start from schematic data. So first, you have to create a new project. I am saving it on desktop. giving it some name. So you can see there is a schematic file as well as PCB file. So first I will create one sample schematic based on existing footprint library and component library that is already present in the KiCAD. So here is the access for the component library that is already installed with the software. So I will make one simple schematic, and you can see there are different things. This is for highlighting the nets. These are power signals like ground, VDD. These are for drawing wires. You can the multiple things I can with for. Here is the shortcut for all the things. So I am drawing one simple schematic using one transistor. See, I'm taking one transistor, NPN transistor. Then maybe I can take one resistor. Or maybe we can copy this register for placing it to at multiple places. And R is the shortcut for rotating. Then I have to take ground also and VDD also. Now connect all the things using the wire. Okay. Now I am placing one connector also for putting some signals from outside. I will just use one connector. 3 pin or 4 pin. So for connecting the nets from this pin, I am using wire. Okay. Now I may connect the signals. I am putting 2 more nets. This is the input signal. So I will just put level input, and here is the output. So I will, here is the shortcut for the putting level. Now I will put more levels for connecting to the rest part of the schematic. This is ground. 3 by 3 plus 3 by 3. Complete. And this is for V in and V out. Okay, so this is one simple schematic. I will do layout for this. And see, now I want to see if this net is connected to this net or not. Then I can simply click here. This is highlighter, net highlighter. So, okay, so this is not connected. Ground is also not connected. Beam is connected. So it can be used for checking whether the signal is connected or not. So ground is not connected. So let me connect it directly. Now let me check whether it's. Oh, still it's not. Okay, maybe there is. So let me connect it directly. Now let's check. Okay, so this is the small schematic for the layout. And now there are multiple ways for assigning the footprint to all the components. So I will assign the footprint for each of the component manually. For this, there is 1, 2, 3, and 4 components. So I will simply double click or just by pressing E on E button on the component, it will guide through the footprint assignment. Okay, so here is the footprint. So I can simply click here and it will it will open the footprint library. So here there are multiple libraries. So I can simply assign any of the existing footprint. So I will just choose 1005. Okay. And I will copy this for another registers. So now this register is assigned the footprint. Now assign the same footprint here also. For the transistor, it's already assigned. And for the connector, okay, let me check them. Or we may choose Barnum also. There are multiple libraries, so any of these can be chosen. 2.54 or 2 mm each. So I 2.54. Okay, so I am choosing this footprint for the connector. Okay, Okay, so all the components that was existing in the schematic is assigned a one footprint. And here is the BOM. Here is the different switch to PCB editor. So from here I will switch to PCB editor, or you can see the BOM. The 4 component BOM can be generated from here. And here also the same thing in a list. All the components is present in a list. So if we don't assign the component footprint using one by one, here is the list. Can be assigned from here just by clicking it. So there are different ways for assigning the footprints. So now footprint is assigned. So let me switch to the PCB editor. So it's already open. Okay. So here you can see PCB editor. These are setting for the grid. File board setup. Here stack up settings. These can be done 2-layer PCB, 4-layer PCB. But we will proceed with the default one, 2-layer PCB. So we will not change any of the parameter. We will simply proceed with the default one. Then first of all, let's draw the PCB outline. So for drawing the PCB outline, we have to select edge cuts. Here you can see different layers, all the layers. Okay, we will see once the component has been placed. You can see different layers can be visible by selecting those. So for drawing the PCB outline, here we have to select the edge cut. Okay. Then select these are different shapes. So I will go with a rectangular or a square. Okay. So you can choose the size 4x4 or whatever.
So I have a small question here. Suppose
Yeah.
I want to have a PCB which has a rectangular body but also a semicircular head on the other side. So can we have that kind of a shape also possible? Like, can I have a circle drawn and then merge two shapes here?
Yeah, it can be done, but
Why I'm saying this is because finally product design mein to we do not even know which shape will be there. Like rectangular
yes,
is
yes,
not really the shape that will always have.
yes.
तो अगर हम कुछ ऐसा करना चाहते हैं तो is that possible with this? अच्छा,
Yeah,
you're saying arc is possible.
yeah. These are different shapes. You can draw a polygon also. Using these things, 3, 4, or any kind of shape can be generated using these things.
Okay. Oh, then in those terms, it is just like paint then. We can,
Yes.
and we can remove these internal boundaries then. अरे
Yes,
मतलब अगर मैं
yes, yes,
है ना
yes, yes, yes.
ठीक है thank you.
And here you can simply define means not if I have predefined size 40 mm by 40 mm, and I can also change the line width. Okay, so like this. So this is the PCB outline. Then we can check for the DRC errors if there is some error. And then we have to resolve that error, then we can proceed further, otherwise it will not work. Okay, so we can see there is no zero error, zero warning. So if I don't assign some footprint here, like if I remove this, it will give error. Or if there is some unconnected nets or anything, then it will give error. Like I have now removed. Now I will simply open. Again, I check the DRC. It will give error. Okay. Yeah, it's giving error. First, actually, I saved the schematic. Then I have to again update PCB from a schematic. Then only that will be reflected. So if I do this, it is showing one of the component is not unassigned, cannot as R1. No. So let me again reassign. Now it's saved. Now update 0. So these are all footprints that has been used in the schematic. So now I will replace wherever you want to place. It can be based on the user requirement. So I am placing component one by one. Okay. I'm just placing for the demo purpose. So component has been placed now, and now it can be routed using this. Okay, so now placement has been done. We have 3D viewer also. So as the component has been, all the component is has been used from library. So all the components have 3D view 3D view also. So we can see how the PCB will look like, the actual PCB. So you can see this will be the actual look. And as net has been not routed, so we will route and we will see how it's coming there. So I'm just routing. And this is actually I'm routing on a single plane. Maybe we can put some here. If there is a two-layer PCB and component is on another side, then in that case you have to place vias. So for vias, just just uh, press V button or yeah, just by pressing V button. So it's now on another plane. So you can put another here for now.
So V is for VIA.
Yes, just by pressing V button. This is just for demo. So, and actually there is no requirement. It can be done on single layer only. Okay, so now let's see how it looks. Okay, so you can see all the tracks is visible in 3D. Now, if I want to have thicker this track width, in that case, just click and increase the width. Suppose I want to have 1 mm width, so just like this. Or select all the tracks. Not selected. By selecting it can be done globally. So let's see 3D viewer. One track is now thicker. Okay. Okay. Now I want to put some text or some logos. Or suppose I want to put one more component. Now it's first version is ready, and I want to modify the schematic and layout. In that case, it can be directly reflected. Suppose I want to put one more component. Let's put one LED. Okay. Now I have saved. Now I will go to the PCB. Then I have to update PCB from a schematic. Then another component will come. Okay. No footprint has been assigned. So let me assign it. Any of LED. Anyone can be taken. Let's take this one. Okay, so now footprint has been assigned. Now okay, now 0 error. And now the footprint of the LED is also available. Now I have to route also these two pins, do two nets. Now maybe must see the 3D viewer. So you can see everything is available. Now we can put some text also that we often want to put the name of the board or anything. So let me put some text on the celestial custom. Okay. So I will put some text on the front, or it can be back. So let me put that text. So I will put some text board. And here the width, height, and thickness for the text. So I'm just taking one value. Can we put? Now it should be visible here. In the similar way, we can put the logos also. If we have some logo, it can be put. So I will, for demonstration, I will import one logo. Okay. So for logo, there is one image converter that converts image into the PCB footprints. So I will use this board source image. Okay. So here we already have some logos. So I will put ST logo. So it can be these formats. These formats are. I will put. And now what should be the output of the logo? So let's measure what is the available space for putting the logos. So let's measure. So here is the measurement tool. I will just put logo here. So you can see it's 15 mm almost. 15 by 9 Newton. Or we may, it can measure like this. So I will save this in the same folder. And I have to just name the logo. So let's name. Now save. Now I have to manage the prints. This is project specific, so it can be saved in the library internal installation folder also, but it can be used locally for some project. So here I will simply use it as project specific libraries. Add existing. I already have. Select folder. Then just press OK. Now the library should be visible. So let me, okay, sorry. So here you can see ST logo. So it's listed. It should be visible. So this converter method, we will just put logo. So you can see the logo is visible. Now there there is sometime we want to place the copper core also on the PCB that can be connected to ground generally for heat sink and better signal transfer. So in that case, I have to simply select the copper. Then add field zone. Suppose I want to put the copper core on the front. So I will simply um, select the field zone, and then it is asking which net you want to connect. So generally it's connected to ground. So I will also connect it to ground. Now I will just select the area. Okay. Okay, so in this area, I want to fill the copper core. So just uh, just by pressing the B button, it fills the copper core. So it is filled on the top. So we can see it on 3D viewer also. So you can see the copper core is visible and not on the back, only on the top. For putting on the bottom, it can be done in the simply just by selecting the bottom bottom layer. Here different layer, we can just see the front or back layers, all layers. These are different options.
So just to add, copper is poured to reduce the EMI, EMC issues. Also, copper is sometimes grounded, or most of the time it is grounded, again to reduce this EMI, EMC. Plus, the PCB manufacturer charges the PCB cost based on the PCB size and the shape, sometimes if there are cuts and edges. So removing copper is actually for them a process because they need to basically, it's done through a chemical process, so it is etched out. So if you are putting a copper pore, it is helping them. I mean to say, it is helping both the parties. As a PCB designer, it is helping you because it is reducing EMI, EMC. It is providing, let me say, the ground to most of the part of the PCB. And
So this is very interesting. एक बात मुझे just clarify करो, जो ये दो components R1 और R2 के बीच में dark area है, is that a ground shielding that you have provided there? Hello, am I audible? Am I audible? Hello? Balmukund, you're not audible.
Am I audible, Anush?
Yes, Alok, you are.
आपके यहाँ कुछ इशू हो गया है क्या? कुछ बोलना है यार आप? हेलो maybe some problem. 1 minute.
बालमुकुंद एक बार म्यूट करके वापस अनम्यूट करिए. Okay, we'll have to reconnect it seems.
Sorry, it seems Balmukund's PC hanged. Just 1 minute. Yeah. Is Balmukund audible now?
So आलोक आप तो ऑडिबल थे. बालमुकुंद
Yeah, I am audible.
yes, you're audible now.
I don't know what is happening. We are able to see your screen, but
Power off.
ठीक है हाँ, नहीं उसमें देखिए नहीं नहीं आपकी आवाज नहीं आ रही है करना इस पे रेड बैंग आ रहा है ज्वाइन पे हाँ कंप्यूटर ऑडियो नहीं आपका तो माइक ही डिटेक्ट नहीं हो रहा देखो माइक्रोफोन ऊपर से बंद कर दीजिए अब बोलिए हेलो हाँ
Now it should be okay. Yeah, so, so sometime back we explained the copper core and gears. So that question was audible or no?
Now is audible. Okay. ठीक है, I think now you can proceed ahead.
Okay. Okay, so layout is okay. Now we can proceed for Gerber generation. Now to add also, this is KiCAD. So if there is some non-KiCAD project, so that can be also imported from here. So, okay, so here is the option import cadastral these projects. So this can also be done. Board file also it can be imported. Some non-KiCAD. These are all supported supported versions. Altium, cadastral. Okay, so for Gerber generation, here is the option. Now we can generate Gerber. So let me. So just select the output directory in which I want to put the files. So here I will create one new folder. So here is a different option. Drill files. For drill files, this is we have to click here, and we can generate drill file. So drill file should have been generated, and also the plot. So it will generate full Gerber file. So let's check on the folder. Gerber should be available here. So we can see this Gerber is here. Full Gerber files is present. Now it can be this Gerber file can be seen in Gerber viewer, any of the Gerber tools. And also there is some calculator tool. Like this can be used for multiple things, also for calculating the track width in some cases. So you can see this can be used for calculating the resistor, via size, track width, wavelength for RF. So it can be used for just by putting all the value, it will calculate. Okay, so for calculating the track width, suppose the track is carrying 1 ampere current and expected temperature rise and conductor length. So suppose I am using for 2 ampere. So you can see this value will change. So the track width should be selected accordingly. Like I am using 6 amperes. In that case, track width should be this and thickness should be this. Okay, so this tool can also be used for calculating the track width. That can be used for layouting. Okay. And here in Garva tool, we can view the Garva we have generated. So I can select the Garva folder. So you can see this is the view from the Garva view. Okay. Okay, so
That's it. Okay, so that's it for today. Maybe it was a bit fast, but I think it's a good reference if you have noted down the different options available, and then I think you can try later on yourself. Any questions so far or any other comments?
I think this was a good introduction for the tool today. What I personally am really looking forward to is now you sharing your distilled experience with us कि भाई अच्छा ये तो भी anyway हमने बहुत basic एक ट्रांजिस्टर के साथ एक इन्वर्टर टाइप्स बना दिया.
Yeah.
What happens if I have to use an STM32 with so many pins? How do I and design something with STM32? Let's look at that in the next session. And more importantly, वही जब हम STM32 देखना चाहेंगे तो what I would really also want to understand is कि पावर राउटिंग कैसे कर रहे हैं हम, कितना बड़ा, जैसे यहाँ पे आपने बात करी कि इस ट्रैक को मोटा करना है, पतला करना है. How to decide which track has to be thick?
Okay.
How to decide which track can be kept thin? How to decide where do I need to put shielding? How to decide, for example, do I need a ground plane somewhere or not? Which components to put on side 1, which components to put on side 2? When do I need to go to 4-layer PCB? When do I need to go to 6-layer PCB? And then how to design those?
Okay. Okay, fair enough. So thanks, Anuj, for these pointers. I would also like that we collect all these questions together. And then because, few things we do it by experience, but to really make it interactive or let me say to be done in a class, it would be good to prepare a little bit. So if these questions can be collected together, then we will prepare accordingly and then address them in a session like this.
Sure.
So I would request Rahul to collect these questions, and then it will help us to prepare from our side.
Sure. So also, for example, अगर हमें कल सेशन करना है तो Rajesh, if it is possible, I don't know, if it is possible, it could be interesting for us to know about some case studies, some experiments that you've done जहाँ पे कुछ fail हुआ, and then how did you recover from there?
Okay,
Bal Mukund and Alok at ST also कि क्या failure दिखा आपको, and then how did you recover from it? I think that is one very very key thing that the students should be exposed to.
Okay.
You don't make the same mistakes. So some case studies, something that you did, वो आपको अपने archives में मिल जाएगा कहीं पे शायद. just if you can, I hope they're not company confidential, and even if it is, you can just blur out the company confidential info around it, and just share with us your experience. कुछ मत दिखाओ, आप बस उस प्रोडक्ट की बात ही कर लो, बिकॉज प्रोडक्ट की बात करना तो कंपनी कॉन्फिडेंशियल नहीं हो सकता. And then just share with us your experience कि क्या हुआ, how did you debug it, how did you identify कि ये issue है, and then how did you correct that.
Okay, so this requires a little bit of thinking, Anuj, but your point is your point is understood. So give us some time to prepare all this, and then we will also look at the different questions which will come from the students, and then we'll try to address it.
Sure, perfect. In the meantime, let us just open the thing also to the students if you have any questions. Sarthak, Danish, Harsh, Digambar.
I hope they are still in the class. Okay, maybe let's stop because it's already 1 hour 30 minutes.
Sure.
So maybe it's a bit too much overwhelming. So let's stop for today, and then we do it next time more focused on the specific questions.
Okay. I think there is one question in the chat window. अगर हम उसको answer कर सकते हैं तो. अच्छा चलो, this is also about the next class, not an issue.
Yeah, custom footprint. Okay. Yeah.
ठीक है, चलिए. Thank you. Thanks a lot, Balmukund. Thanks a lot, Rajesh and Alok.
Okay. Thank you, everyone.
Looking forward to the next session, and I hope the students will be able to resolve their queries and ask more questions, be more interactive in the next session there.
Yeah. Okay. Thank you.
Thank you. Thanks a lot.
Thank you.